Okay, so let's go over these answers here with the squirrels. And so we should have, when you count up the frequency of the black phenotype, you should have 100 squirrels here, including the one to draw in. And so you should have had over here a 75 out of 100, which would give you a 0.75 frequency, and that's of the black genotype. And then for the gray, you should have 25 out of 100, which gives you a 0.25 frequency. And those are your two phenotypes for that. And then it's asking you about the different genotypes. And so the frequency of the big B genotype, and so that is 25 out of 100, which gives you 0.25. The frequency of the big B little b would be all the ones that don't have the big B, so that would be 50 out of 100, which gives you 0.5. And then the frequency of the little b, all these ones that aren't shaded in, and that's 25 out of 100, which gives you 0.25. So therefore the frequency of the big B gene happens to be 0.5, and the frequency of the little b gene is 0.5 as well. All right, and so that is the squirrel population. So if we turn your sheet over, let's go with this. All right, so the frequency of two alleles is 0.1 and 0.9. So what that information is giving you is the big A frequencies. Notice there it says of two alleles in a gene pool. So we're just talking about the allele, so we're talking about P and Q here. So P is 0.1, Q is 0.9. So when it's asking you then, that's what you're given, what is the frequency, or what's the percentage of the population of heterozygous individuals? That's, we're looking for 2PQ. So we multiply 2 times 0.1 times 0.9. And so when you do that, you get 0.18, but it's asking you again about the percentage. So you multiply that by what? By 100, and you get 18% of the population as your answer. Number 2 says the big B for white wool is dominant over the little b for black. In a sample of 900 sheep, 891 are white, 9 are black. Estimate the genotype frequencies. So that's genotypic frequencies. So that is like P squared, 2PQ, Q squared in this population. How many sheep are these genotypes? So big B is white and little b is black. So remember, we want to focus on the recessive. So in this case, the recessive are the 9 are black. So we wanted to get the frequency. So what's the frequency of the black genotype? Is 9 divided by 100. So that's what we know. 9 out of 900 are black, and that's little b. What information is that in our Hardy-Weinberg equation? That is Q squared. So now we can take the square root of that to get Q. So you divide 9 by 900 and take the square root of that to get Q, and you get Q is 0.1, therefore P is 0.9. They have to equal to 1. So once you get that, then you can figure out the frequencies. So we want to figure out of the 3 different alleles, or 3 different genotypes. So big B, that's P squared. So P we just figured out is 0.9. So 0.9 squared is 0.81. But that's not what it's asking you. It's asking you how many sheep are big B. So what this is telling you is 81% of the population is big B. So we take 81 to get our answer, 0.81, and we multiply it by 900, because there's 900 total sheep in the population, to give us 729 that are big B. So that's our first answer. Then for big B, little b, that's 2PQ, which is 2 times 0.9 times 0.1. And so, and then we take that number and multiply it by, multiply it by 900, and you end up with, at the end, is 162 big B, little b. And then lastly, little b is Q squared. So Q is 0.1 squared, all right, and then we multiply that by 900, and you get your total is 9 little b little b. If you add these up here, it equals to 900 sheep. All right, so then number 3, the big T allele is the ability to taste a particular chemical, and it's dominant to the little t allele, which means you can't taste it. At Cornell University, out of 400 surveyed students, 64 were found to be non-tasters. How many students are heterozygous for this trait? So again, we want to focus on the recessive. So 64 were found to be non-tasters. That's the recessive because that's the allele of the inability to taste. So 64, what's our frequency then? 64 out of our total, which is 400. Our little t, which is what that piece of information in Hardy-Weinberg is q squared. So then we divide that out and take the square root, and we get q, and if you do that, q is 0.4, which then means that p is 0.6, so that they equal to 1. So then it's asking you how many students are heterozygous, so that's 2pq, so we take 2 times 0.6 times 0.4, and we get 0.48, but it's asking you how many students. So what this is, that's the frequency, and so you have 400 students, and 48% of them are going to be heterozygous, so we take 4.48 and multiply it by 400, and you should get 192 that are heterozygous students. 192. Number 4. Blood type here. Rh positive is produced by the dominant gene, while Rh negative is by the recessive. If 84% of the individuals are positive, what are the frequencies of the alleles big R and little r? So we're looking for P and Q because it's asking you frequencies of the alleles. So that's P and Q. So 84% are positive. Positive is dominant, right? And so we can't use that information because dominant is going to be big R, and big R, little r. So what we can do is then figure out the recessive individuals from that. And so if 84% are positive, what does that tell you about how many are negative? 16% are Rh negative. So that is, 16% is the same as 0.16. Which is q squared. Those are the individuals that are little r, the Rh negative. So that is the same as q squared. So then you take the square root of that to get q. So q then is going to be 0.4, which means that p is going to be 0.6. And that's your answer. That's what it's asking you. All right, let's flip this over and do the next one. So we have a rare disease due to a recessive allele, which is lethal when homozygous, occurs with a frequency of 1 in a million. How many carriers of this allele are there in a town of 14,000? Carriers. That's heterozygous, so we're looking for 2pq here. All right, and so it gives you this stat that 1 in 1 million are 1 in 1 million are homozygous. It's due to a recessive allele, which is lethal when homozygous, occurs in a frequency of 1 in a million. So that's little r. That's the individuals that are little r. What piece of information is this in the Hardy-Weinberg equation? This is q squared. So therefore, how do we do q? We take this and take the square root of it. So when you do that, q would be 0.001. All right, and then so then P would be 0.999, right? And so then we're asking carriers, 2pq, we're going to use this, so 2 times 0.001 times 0.999 gives you what? 0.001998, something like that. But that's not what it's asking you, that's the frequency of the heterozygotes. So it's asking you how many of them in a town of 14,000. So we take this and multiply by 14,000, and you should get roughly around 28 individuals that are, I think it's 27.97 something or other. So I just rounded up to 28. So that gives you about how many carriers there are. All right. And lastly, you have this study that shows that 9% of the natives possess an allergic reaction to coconuts. This reaction, which appears to be an immune response similar to, let's see, immune response is thought to be, this is a typo, is thought to be due to the action of a recessive gene. All right, so the population is in the island a total of 5,000. So what does that tell us? If there's 5,000 individuals, there's a total of 1,000 alleles determining this trait on the island. Or sorry, 10,000 alleles determining this trait. All right, so it's telling you that 9% have the allergic reaction, and it's thought to be the action of a recessive gene. So 9% of the individuals are little h. So that's what we're given, all right, this information. So that's good, that's the recessive. And so remember, we always want to focus on the recessive. So little h. So this is, so when we look at 9%, 9% is the same as 0.09. So 0.09 is little h. What information is that in the Hardy-Weinberg equation? That is q squared. It's the frequency of the recessive genotype. So then what you do is you take the square root of 0.9 to give, or 0.09 to give you the what q is, and so then you should have that's 0.3, and then p would be 0.7. So we can figure that out. So then that's what this is, the frequency of the big H gene, that's p. So p we just figured out is 0.7, and the frequency of the little h gene that's q, and that is 0.3. So then, it says blank is the number of little h genes on the island. So little h genes, the number, it's not asking you the frequency. So little h is doing, the frequency of the gene is q, right? And q is 0.3. So this is the frequency of little h. So what does that mean? What does that tell us? That 30% of the genes on the island are little h out of all the genes. So how many genes are there? There are 10,000 genes. And so we know that 30% of those genes are Q. All right, so therefore, what's 30% of 10,000? Say 10,000 times 0.3 gives you 3,000 genes. So 3,000 little H genes on the population, or on the island. So then the next three are about some genotypes. So is the total number of homozygous non-allergic. So non-allergic, remember, is non-allergic is dominant, right? So is homozygous and dominant. So we're looking for big H, big H. What is that in our Hardy-Weinberg equation? Big H is p squared. So so when you do that, p is 0.7. So we take 0.7 squared, and you get 0.49. That's the frequency here, but this is asking you the total number. If it said frequency of this, you'd write 0.49 here. It's asking you the total number. So how many individuals are on the population? 5,000. So we multiply by 5,000, and when you do that, you should get 2,450. All right, the next one, the total number who carry the little h but are phenotypically normal. So what is their genotype? They're big H, little h. So in our Hardy-Weinberg equations, that's 2pq. 2pq then is 2 times then 0.7 times 0.3. When you do that, you get 0.42. That's the frequency. Again, it's asking you total number. So we have 5,000 individuals on the island. Multiply it by 0.42. And you get 2,100, 2,100 on the island that are big H, little h. And lastly, this is the recessive, homozygous recessive. So this is little h. So it's q squared, and that's the frequency of the genotype. So we take 0.3 squared, is 0.09, and then it's asking again the total number, not the frequency, so we have to multiply it by the total in the population, and when you do that, you get 450. All right, and so that is how you solve it. If you have any questions on this, I'll ask if anybody has any questions on Monday. But it's real important that you know how to do this and get your questions answered. All right, I'm going to make the next video now.